Okay, we are going through the capacity and level of service analysis for uninterrupted flow facilities. Okay, we defined them, we looked at the definitions, the properties, the definition for each level of service, a speed flow curve, and the adjustment factors. Last time we were talking about the free flow speed calculation, and again to remind you that you don't need to do it for your projects because you have observed free flow speed. Okay, and then using the free flow speed you can do operational analysis to find out level of service. You can do service flow rate analysis to find out service flow rate and service volume, or you can do design analysis to find out number of lanes. In all these we need the factor for heavy vehicles. So in this factor we need the equivalency factor, and that depends upon terrain. I showed you this graph, so you can select your terrain conditions based upon the length and the gradient. And then you have to select one of these tables, and the gradient can be a combination. Okay, so I showed you this one example where you can calculate the combined gradient. If you have multiple gradients on your segment, you need to combine it using the average gradient method. So you have to calculate the total difference in height divided by the total length. Okay, so this example had two gradients, and there are some more examples which you can try, which have, some of them have more than two as well, I believe. Okay, but the method remains the same. You have to calculate the total height and the total length. Total length of each gradient is given, you add them. Okay, and gradient multiplied by length will give you the height. Okay, so again you will do it for each one and then you add them. Clear? Okay, but you still have to do it. You think doing this will shake your mind and you understand everything. It's not like this. Okay, if your mind was made up of concrete, then this will work. Okay, it will compact things. Anyways, I told you last time that there's a sequence of examples. Even Dr. Rashid was telling me when he came to the class that you have too much explanation without any example. So now you will see these examples and you will understand why was the first lecture like this. Why was not? D minus.
You're making a mistake. Because you already take the class.
Yeah, I know. You don't know what I do with people who retake the class. They give me new jokes. Okay. So we have a freeway, an old freeway. It has 4 lanes, 10 feet lane width. Lateral obstruction is 0 feet from the road. So there is no distance between the road and the object on the side of the road. The question is, when they say no distance, they are measuring the distance from where? What do they mean by the road? From the lane.
To the edge of.
To whatever. To whatever. Okay. From the lane to whatever you have. Okay. Ram density is given, terrain is given. Trucks we have 2%. The peak hour factor is 0.95. Okay. In all these examples, the first thing you need to look at is the free flow speed. Okay, if it is not given, you will calculate it. Okay, so what's your first step to calculate what? Free flow speed, and check your message on the WhatsApp. Right? For me? Why? No, you will give it to someone. I know. Next time you see this guy, you go over him. Right? No? Okay. I had some students like this in Pakistan. I have your picture. Then that's why I ran away from Pakistan. I came here. Now people are taking pictures here as well. I have to go somewhere else. Running out of countries. Okay. First thing is you have to find out the free flow speed. Free flow speed for freeways. There are two equations, one for each type of highway. So this is the equation for freeway. Okay, so there are three things in the equation. One of them is written with the question, which is what? TRD. Okay, so TRD is no problem. Okay. Okay. The other factors are for lane width and letter clearance. This gives you factor for lane width. My lane width is 10 feet. Okay. So the factor is again what I said earlier, you don't put lane width here. For TRD you put the TRD itself, but for lane width you will not put 10 feet here. You have to come and look for the factor of 10 feet. Got it? The next one is letter clearance. Letter clearance is 0. Okay, and I have 4 lanes. Okay, so what's the factor here? 0 feet and 4 lanes. What's the factor? 3.6. Why not 1.2? Yes. Okay, 4 lanes are total. This is one direction. There are total 4 lanes. So 2 lanes in each direction. No? There are 4 lanes on the highway. How many in each direction? This is what I said. 2 lanes in each direction, the factor. Okay, so the factor is 3.6. Okay, how much is the free flow speed?
52.6.
Huh?
52.6.
52.7. Okay, so free flow speed is done. Okay, for operational analysis, now you go and check what equation I need to use for the operational analysis. Okay, what equation I need to use for the operational analysis. This is the equation. Now somebody open the question. You have the equation in front of you. What are the things which are given in the question to use in this equation? Peak hour factor, which is how much?
0.95.
Who was that?
0.95.
He said, I will not talk today. And I know the reason. You shouldn't, obviously. Yes, what other thing is given?
Number of lanes.
Number of lanes, which is how much? 4?
2.
You said 4, right?
4 total direction lanes, Victor.
Yes.
4 total lanes.
4 total lanes.
Yes. We didn't specify.
Yes.
Yes.
Okay, but we will take 2. Because if we take 4, he will get foot marks, which I don't want. Okay, now pay attention. You will make this mistake, one of you at least. Okay, in the exam. For freeways and multi-lane highways is directional analysis. So each direction will be taken separately. Okay, each direction will be taken separately. Keep this in your mind for your term projects as well. Okay, so I don't want to see 2,000 here, 3,000 here, total 5,000, and you are dividing by the number of lanes. This doesn't work like this. These equations do not work like this. Okay, if you have 5,000 together, it will be completely different. The traffic will be completely different. You are mixing 2 directions together, you will be getting different answers. Okay, the numbers could be correct. Okay, but you will get different answers. Okay, so we take level of service for each direction separately for any type of highway. Okay, so
If there is one direction that have more than lanes,
Uh-huh.
one direction have 4 lane and the other direction have 3 lane.
how,
Our project
The extra lane is doing what?
Number of lane will be 4 for one direction.
Why?
I don't know.
Can be an addition.
For what?
For more volume.
For more volume? We don't do this. It's not number.
Bahan we do it.
Sorry?
Bahan we can do it. There's congestion. Simple-minded people.
Simple-minded.
Lane.
Yes.
Then also congestion.
You have to check if that lane is extra and extra for some specific turning. Okay? Then you need to see if it is continuing. If it continues from start to end, then you count it. If it is just near the intersection, 100 meters before the intersection, the lane comes, this is separate. Now this will be counted when you are doing the analysis for the intersection. You are not doing for the intersection, you are doing for the segment. Okay, for the segment, the lanes which are added for the intersection, even if they are added earlier, we don't count them. Even if they are added earlier.
So it depends on the entire segment. that
Entire
you-
segment. Okay, that lane must be in the entire segment. Okay. Which other thing is given in the question?
Distance factor.
Huh?
Distance factor for ambiguities.
Is given?
No, we have to calculate.
We have to calculate. What other thing is given? Okay, so FHV will calculate. What other thing is given in the question? Huh? Flow rate, we will calculate. What is given? Something is given, right?
Rolling terrain.
Huh?
Rolling terrain.
Rolling terrain. And what else is given?
2% trucks.
2% trucks. Okay, let us get done with. Okay.
Percentage of heavy vehicles.
Okay. We want to calculate heavy vehicle factor. Yes. Okay, let us do it. Okay, it's rolling terrain. So my EHV is 3. Okay, percentage of trucks for your convenience to put in the equation. Okay, so how much is the FHV? Okay. Again the same question. What is left? V. So this is given in the question. Okay. How much is that? 3,000?
I don't know.
Why did you say 3,000? How much is V? 3,000? Okay. This is volume. Keep in mind, not flow rate. This is flow rate. VP is flow rate. Okay, how much? Yes. $1,600. 54, 45. Okay. After you calculate these two things, we will go and see how can we calculate the the level of service. Okay, level of service comes from here. Okay, to calculate level of service, I need density. What is density? Flow rate upon speed. This is density. Okay, flow rate upon speed. Do you have flow rate? Yes. Do we have speed? Yes. Free flow speed. Okay. Can I use it? Yes. You can use it, obviously. Who will stop you? Free flow speed can only be used if your flow rate is in this region, which is before the break point. Okay. Free flow speed is the speed of the traffic in one particular condition. Okay. But your flow does not remain in that condition. Okay. You don't have always free flow on the road, right? Sometimes you have traffic jam. Sometimes you have something in between, which is not free flow, but which is not traffic jam as well, right? But your speed will not be free flow speed then. You get the point? Okay. So every time speed cannot be used for calculating, free flow speed cannot be used for calculating density. Okay. You have to see in which condition your traffic is. Okay. Is it in free flow condition or is it in some other condition? What is the limit between them? My breakpoint. Okay. How to get the breakpoint? Yes. This is the equation. Yes.
Can you repeat?
Repeat what?
What?
I need to calculate density. Density is flow upon speed. I have flow rate. Okay. At this flow rate, do we have free flow condition? Yes. I can use free flow speed here. No. I have to get some other speed. Okay. So now I'm checking, am I in free flow or not? So, right now, these are the adjustment factors. If you remember, we discussed them for weather, incident, and work zone, and blah, blah, blah. Okay. The question does not state any condition for adjustments. They did not say anything about weather. They did not say anything about work zone or incident or anything. Okay. So I will not apply the adjustment factors. I will use the equation plain and simple. 1000 plus 40 minus 75 minus free flow speed. That's it. Okay. You forget about the adjustment. You forget about this one. You forget about this one. Okay. How much is the breakpoint? 16.
90.
Okay. The breakpoint is more, flow rate is less. Okay. The breakpoint was more, the flow rate is less. So I'm in this portion behind the breakpoint, right? Behind the breakpoint. Behind the breakpoint is free flow. Okay. So at this flow rate, I'm in free flow. That means this speed is free flow speed. Okay. So now I can calculate density as my flow rate upon free flow speed. Which is how much? Okay, this is your density, and these are the ranges for level of service. Which level of service you have? Yes. Which level of service you have? D. D? Yes. Okay. Let me summarize what we did. This was the question. The highway data was given. You are required to calculate level of service. Okay. First thing you do is find out free flow speed if it is not given. Okay. Second thing is you find out VP. Okay. For VP you need the factor for heavy vehicles. Okay. So this is what we found. Then we find VP. Okay. Then I have to calculate density for level of service. Density requires flow and speed. Flow I already have. I'll use this value as it is. Okay. But speed can be free flow or it can be something else. How do I check? I'll check with the breakpoint. If you are behind the breakpoint, you are free flow. You can use free flow speed here. If you are ahead of the breakpoint, you will use the other speed. Okay, we'll come back to it. Clear? Okay. So once we decided, we calculate the density and the ranges are given from the highway capacity manual, which tell us If this is your density, how much is your level of service? Clear? Any questions? I don't understand this as well. Whatever. Any questions? Yes.
In your breakpoint, why you didn't consider the CAF and
Okay, tell me which adjustment can I do from this data?
freeways speed?
Huh?
Freeways speed.
What? Tell me. I don't know, but do it. Very good. Okay. I'll come to it. Okay. Now you got level of service D, but in free flow condition. Free flow condition is good or bad? Free flow condition is good or bad? Good, right? Free flow condition is good. D is good or bad? D is good or bad? Tell me. Not good, right? Okay, so there's a mismatch, right? We are in free flow conditions, but the level of service is still D. What's the reason? It should not happen. It's not normal. Okay. The problem is, if you look at the question data, how much is the lane width? 10 feet. Okay. How much is the lateral clearance? 0. These are the minimum values. Okay. So your road is very narrow. Okay. This much will not be even allowed in Bahrain. This much width will not be even allowed in Bahrain for any highway. Okay. Got my point? So, like even when you are doing construction work, they would prefer to have at least more lane width than this one. Okay. So, because of the narrow road, even free flow conditions are having very poor level of service. Okay. Then, on demand, we will apply the adjustment factors now. Okay. So now, imagine you have the full question, this one, plus additional details like this. Then you can go for adjustment factors. Because these additional details are now about something on which you can apply adjustment. Okay. So now read this part, what is saying. In the same example, okay, we have a weather event now. Okay. If I did not give any weather event, how will you apply the adjustment? You will tell me, no, doctor, do it. Huh? Just like my daughter. She will tell me every morning, let's do it. This thing. Today, this is your task. This is your mission. Do it or die. Okay. But now we have a weather condition. So until, the point is, until some condition for adjustment is given, you cannot apply the adjustment. You don't think about adjustment. Okay. What are the conditions for adjustment? There are 4. One is what? Weather. Then? Yeah, everybody talk together. So nobody can understand. Yes.
Work zone.
Work zone. Okay. What else?
Incidents. Incidents.
Incidents. Yes, tell me. So why you are wasting time? What else?
Driver population.
Driver population. Okay. So until something is given about these 4 things, no adjustment required. Okay. Now, adjustments are made for capacity and free flow speed. Adjustments are made for capacity and free flow speed. Okay. So we have free flow speed, which is unadjusted. Okay. So first thing is I will make the adjustment to free flow speed. Okay. It is weather, so easier. This one. Okay. SAF means speed adjustment factor, and the table is for weather. We have medium rain, which is the first one. Okay. And our free flow speed is 52.7. 52.7. Now, remember one thing. Here, if you look at the values, they are very close to each other. Okay. In some cases, they are repeating as well. Okay. So even if I do interpolation, nothing. If I do interpolation here, it will be to the 3rd or 4th decimal place. The change will be in the 4th or 3rd decimal place. Okay. Again, you will round it off Either you will be here or here, right? Okay, so there is no interpolation here. There is no interpolation here. Okay. This is when you have value in between. So if I have a value 61, I will not do interpolation. I'll take the nearest value. Okay.
So 62.5.
62.5.
Exact in the middle.
Very good.
Round down, round up.
Whatever. Okay. I did not even ask whether it was, where is it? 1644 point something or 45 point something. I did not even ask. Okay. Now because of him, you may lose some marks. I'll start looking at rounding up and rounding down. Okay. Now what will happen if you are out of the range? Okay, and this is true for all the tables. Okay, not only this one, all the tables. When you are out of the range, we will pick the last value. Okay, we'll pick the last value. Clear? Okay, so the last value is 0.96. Okay, so this is my speed adjustment factor. Okay, clear? So the final speed will be this multiplied by this. So how much is this now? The adjusted speed 50.6. Okay. Since we already did one trial, right, without the adjustment factor. Okay, so we'll go in the same step. We'll go by the same steps. So the first step was free flow speed. Free flow speed needs adjustment. I did it. Second step was what? Calculate VP. Okay. Calculate VP. Okay. For VP I calculated FHV. Okay. FHV has no adjustment for weather. So it will remain same. VP has no adjustment of weather. So it will remain same. Okay. After I calculated this, I checked it with breakpoint. Now breakpoint equation has an adjustment factor. Okay, it has an adjustment factor and it is using adjusted speed as well. Okay, so now 50.6 will go here. Okay, and I need to find the capacity adjustment factor as well, so I can put in the equation. Okay, again going by the same rule, you take the last value. Okay, capacity adjustment factor 0.94. Okay, what is my new breakpoint?
1744.
Huh?
1744.
It increased. How?
Yeah.
10 or 17?
Yes, because you the 74
40, 25, 75 minus
0.95.
huh?
0.94, so
0.94 is what? 94 square. We are multiplying this whole thing, right? We are multiplying this whole thing by 0.94 square. So it will, you are only increasing or decreasing speed by 2. But you are multiplying with 94 twice. How much is this? Then 1744. You are with him now. Nobody is with me. Huh?
Yeah,
1745.
because the previous was wrong.
The previous was wrong. See?
Was the one not?
This guy gave.
I'm going to the
it's good.
How much was this? 19?
I don't know.
1745 is this one.
189, yeah.
1890. Okay. It was supposed to decrease, obviously, it's supposed to decrease. When you have an adjustment, the values are supposed to decrease. The capacity will decrease, the breakpoint will decrease, the free flow speed will decrease, your grades will decrease, and everything. Okay, you have the whole package. Okay. Now, with the new breakpoint, can I still use the free flow speed? No? I can still use it, right?
Yes.
With the new breakpoint, I can still use it because the new one is also higher than VP. So I am behind. Okay. So, but the density will be from this new free flow speed now. Okay. So what is my new density? Point.
That's 2.5.
The value was wrong by 200. I didn't say anything. You care? You think I care about 0.1? Okay, level of service? Huh? So you are talking now?
I will leave it.
Okay. So the weather conditions did not change the level of service. So the overall traffic is still the same. But that doesn't mean everything is same. You see the free flow speed has reduced. So the weather conditions will reduce the free flow speed. So even in free flow conditions, our drivers will go slowly, which makes sense, right? If there is rain, medium rain for most of the times, the pavement will be wet, the visibility will be lesser, and so the speed will be lower. Okay, when the speed is lower, density is high. You can see density is high. Okay, but it does not shift the traffic too much from one condition to the other condition. These things are increasing, but within the same range. Clear? Okay, now we have a multi-lane highway example. 4 lane, volume is given, 12 feet, 4 feet ladder clearance. Okay, 10 access points per mile, 10% trucks, peak hour factor is given. Segment has 3.5% gradient, 1.25 miles in length. Okay, the base free flow speed is 65. What is the level of service on upward and downward gradient? Okay, so we have to do it for both directions. You did something similar for in the highway course as well when you were designing the curve and you were taking the gradient. You do the same thing, right? Okay, the gradient is upward in 1%, so it is downward in the other direction. So if you take the entire highway, you have to take both. But again, going back to my point, they are saying do each direction separately. They did not say, okay, 22,601 direction, multiply by 2, do it for the whole highway. Okay, we cannot do it like this. Clear? Even for level or rolling terrain. Okay, now tell me what was the first step. I told you the first step in all these examples is always the same. Free flow speed. If you don't know it, you have to find it out. But now the free flow speed equation will not remain the same. Okay, for we have to go back for the factors anyway. Okay, this is the equation for free flow speed for the freeway. Sorry, for the multi-lane highway. Again, there is one thing in this equation which is given in the question directly, which is what? There can only be one thing. Which is what? What is given in the question? BFFS, right? Okay. Base free flow speed. Okay. Other things, there are adjustment factors for them. Okay. The first one is for lane width. How much lane width is given? 12. Now you see this is the maximum value or the optimum value. So the conditions of the road are slightly better now. Okay. You are giving more lane width. Got it? Okay. So, yes. That's an old joke. Why are you like?
What is BFF?
Base free flow speed.
I didn't know what.
Okay. So for this one, the factor is 0. Okay. Then the next one is the lateral clearance. How much lateral clearance is given? How much lateral clearance is given? 4 feet. On which side? I'm not asking you. Which side? Median. Median side is 4 feet. Okay. What about the other side? No, not the maximum. We are taking total. That's why I'm asking both sides. We need total here. Total. This plus this. Okay. What is it saying?
4 feet clearance at the both side and in the median.
Okay. So 4 feet on both sides. It's mentioning 4 feet on both sides. Okay. So now we can take 8. Total 8. Okay. Clear or not? It is mentioned 4 feet on both sides. That's why. Okay. It's not like if they are saying 4, I will take 8. No. It's not a rule. Okay. So 8 feet clearance, 4-lane highway. 4-lane highway. Okay. 8 feet clearance, 4-lane highway. The factor is we have a median, right? We have a median. It's written, divided. Okay. So for median, the factor is what? Okay. Access points 10 per mile. Access points 10 per mile. Okay. So 65 minus all these things. How much? 61? This is the problem here, right? What was the factor? 2.5. Okay, 61.6 with 2.5, right? Okay. What was the next step? We did VP, right? And VP needs a factor for heavy vehicles. Okay, VP needs a factor for heavy vehicles. Okay, so I need percentage of heavy vehicles, which is given how much? 0.1 percentage of trucks. 10%. What are you saying? 0.
I think it's for the
10% trucks. Okay, I need the equivalency factor. Okay, I need the equivalency factor. For equivalency factor, I need to decide whether I should use the big table or the small table. Okay, that depends upon this chart. Okay, my gradient is how much? 3.5%. Okay, so either I'm here or I'm here, right? Okay, what is my length? 1.25 miles. More than 1 mile, right? The length is more than 1 mile. Okay, so I'm here. Okay, so this is the big table. Length is more than 1 mile. Okay, so I'm on the big table side. Now there are 3 big tables. Okay, and they depend upon the distribution of single unit trucks and trailer trucks. What is written about them? Standard mix. Okay, standard is 70-30. Single unit 70, trailer trucks 30. This is standard. Okay, if they say standard, default, okay, it all means the same thing. Okay, which is 70 single unit, 30 trailer. This one. Okay, now the gradient 3.5% and the length 1.25 miles. 3.5% is here, length 1.25 miles. I need to insert the percentage of trucks, which is 10%, right? Okay, so 10 is this one. Now this is this upward or downward? upward because we looked the value for plus, right? Positive 3.5%. So it is upward. But the question says do the analysis for downward as well. Okay, so it cannot be the same factor. Okay, so we have to look for the downward gradient. Okay, it is, you only have minus 2% here. Okay, in the old manual they were saying okay, you take it for whatever you have for level. Okay, but in this manual they are not saying this. Anyways, but I told you in these tables, yes,
How did you get 2.96?
3.5% gradient, 1.25 mile length, 10% trucks.
Should be 3.09.
Is 2.96. If you are asking for the number is 2.96.
Okay.
Okay, this number is 2.9. Just trust me. I know you don't, but just for this one. Okay. Now, going back to the point of negative gradient. Okay, so you don't have minus 3.5% here. You have only up to minus 2. Okay, so now you're going out of the range of the table, right? So what did I say in that case? You take what?
1.96.
The last value you have. Okay, the last value you have in the table. Okay, so forget about the gradient. 1.25 miles length. Okay, and 10% trucks. 1.96. Okay, even for minus 3.5, even for minus 4, this will remain the same. We don't have any other values. We don't have any other table. Clear? Okay. In the old manual, like I said, they made it very simple. They said, okay, if you have negative, take it as a level terrain or now forgot myself. They said, okay, you go back to the small table and take the value of level or rolling terrain, one of those. Okay, which is very close. If you see the value for level terrain, it is 2. And what is the value here? 1.96. Okay, and if you look at all these values, they are around 2. Okay, but obviously they want to be more accurate, more precise. So this one is for upward and this one is for down. So that means you will have two values of FHV. Okay, this is for up. How much is that?
0.83.
0.83. And for down, you just replace this with 1.96. How much is that?
0.91.
0.9. Okay. So the next step, we did this for VP. Okay. So how much is my VP? The given volume is 2600. Peak hour factor how much?
0.88.
Okay, if I'm doing it for upward, I'll take 0.83 here. It's 4 lanes, so 2 in each direction. 17779. Passenger cars per hour per lane. Yes.
Why is it
4 lane, one direction, 2 lanes.
4 lane in each direction?
Who said that? 4 lane each direction? No. They said 4 lane highway.
Why you choose 8 before?
When
Oh,
direction?
okay, okay.
Okay. Now replace it with 0.91. How much you get? 1623. Okay. So I need to calculate density for the level of service. For density, I must decide about this speed. Okay, I must decide about this speed. For speed, I need to check if I am in the free flow condition or not. For that, we have to take the breakpoint. Okay. Now here it is simpler. Multi-lane highways are simpler. Okay, because of 2 reasons. Okay, multi-lane highways are simpler because of 2 reasons. First reason is you can see it here. The breakpoint is fixed. I don't need to calculate again and again. Secondly, okay, so multilane highways are simpler because of these two reasons. Now you know which one will come in the exam, right? Huh? Yes, prepare well for it. Okay. So if you look at the breakpoint, it's 1400. If you look at VP, up and down, both. They are both more than that. That means no free flow. So I have to find out the speed. From where do I find out the speed? We have an equation, okay? And the equation is here. Okay, this is called the balance of life. Which one is simpler? Yes. Okay. So free flow speed you have DC. This is DC. Density at capacity. It's fixed from the manual, from the high to capacity manual. So this one is 45. Okay. This is 1400. This one will change for up and down each case. A is given in this table. 1.0. The only thing which I need to calculate is what? I need to calculate one more item here, which is C, capacity. Capacity, this is the equation of capacity. Okay. So how much is the capacity? Whenever you calculate capacity, you check it with the range. Okay, so you are in the range, so we can take this value. Now give me the speed for up condition. So you use this VP. Okay, nothing else changes. When density is 31, we know that the velocity of service is D. We found it in the last example as well. Okay. Now for the upward, you will recalculate S. VP will change only. Only VP will change for the upward. Okay. The rest of the items will remain the same. And then you get new S and new D. Okay. And you can finish it off, but it is almost the same. Okay, it is almost the same. The point is that you can see the flow rate. Okay, you can see the flow rate for upward and downward condition. Okay, the upward is higher. Okay, this is because of the effect of what? Why upward flow rate is higher? Everybody did it? Yes, why the upward is higher? Because of the effect of what? We cannot say because it's upwards I have more cars. We don't have more cars, right? The volume is same. So what made the upward higher?
Slower.
The heavy vehicles, right? The effect of heavy vehicle increased for upward condition. Okay? And that effect is shown in the flow rate itself. That's why this is a very good metric to include here. Okay, because it compensates for the effect of heavy vehicles and everything. Okay, now you don't have to worry about what will happen with the heavy vehicles when they are going upward. Okay, it is part of the equation which is calculating the flow rate. Got it? Okay. Okay, the C should be, so for the other direction you should be getting C for downward. But this is because of the effect of the gradient. What is this? What did I do? Yeah, okay. Okay, now play,
What about the other
for what? It's D. 31, we did the same table. And the last question was also 31, D.
27.
Sorry?
27.
27, okay, so we have C then.
No,
We have C.
26. Oh no, it's freeway.
Same. So we have still D, right? D or E? D, right? D.
Both.
Both are D.
But one is a higher D. One is D.
One is D, one is D minus.
Do D minus D plus and D.
D plus and D. Okay. We have other candidates as well. See? He's making grounds for himself. There will be D plus. If I get D, it will be D plus. If he gets C, it will be D minus. You need friends. Is your friend? No. Okay. Now we have a different example. Pay attention to this one because it needs a whole graph. You will draw the graph in your term project, but you will not do it here. I'll explain the procedure. Okay, we have a new highway. The design volume is given. Okay, and what else? Peak hour factor is given. We have familiar users, 15% trucks. Okay, and it's a heavy mix now. The heavy mix means more trailer trucks and less single unit trucks. Ram density is given. There's a long segment which is on level terrain, but there's a 2-mile segment. So we are designing the whole highway, right? The whole highway can have many segments then. Okay, so that's why you have this. So we have two types of conditions. We have one which is level terrain. We already decided it's level terrain. Okay, the other one is extended gradient, which is a 2-mile segment of 4.5% gradient. Okay, so this is as per their design. This comes from geometric design. Okay, this gradient is coming from geometric design. Okay, so you finish that and then you come to this analysis. Okay, so this is the flow. You have to finish the geometric design first and then you come to this one. Clear? Okay. So what do they want? They are looking for level of service C. Okay. If level of service C is not possible because of any reason, then we can go to level of service D as well. Okay. Clear? So design analysis, we are trying to find out number of lanes. Number of lanes which will maintain C. Okay. We are trying to find out number of lanes which will maintain level of service C. Clear? Okay. What is the first step? Free flow speed. Free flow speed as an equation, right? It's a freeway. Equation for freeway. Okay, which of these things is given in the question? Ram density is given. Same as before. Ram density is given. Which is?
0.5.
Where is it? 0.5. Okay. Do we have lane width? We don't have. Do we have letter clearance? We don't have. Even if we had letter clearance, we still need the number of lanes, right? You cannot decide. Okay. So, what do we do? Now, assume, yes, assume. if you have to assume, then the best value is the right starting point, right? If I have to assume something, I'll start with the best value, right? Okay. So if I go to these tables which are giving me the adjustment factors, okay. So what's the best value here? 12. At 12, I'm not interested in the value right now. I'm interested in the factor. So at the best value, the factor becomes 0. Okay, so that is the important thing. Okay, even here. Now you can see if I assume the best value, number of lanes doesn't matter. Okay, because at the best value, this becomes 0. Okay, so the only thing you have to worry about is this thing. Okay, 75.4 minus only this item. How much? Okay, we are doing design analysis. Okay, so the next step is not VP. The next step is this one. Okay, again, somebody open the question and tell me which of the things are given. Is DDHV given? The design volume, is it given? Right? Okay, is peak hour factor given?
Yes.
How much?
0.85.
Okay. FHV I need to calculate, right? I need to calculate FHV.
Yeah.
FHV, what is the percentage of heavy vehicles? 0.15 or 15%. Now EHV depends upon the terrain. We have three terrain conditions. We have three terrain conditions. Okay, one is level, and the other one is what? In the question. What does it say about the terrain condition? We have level, we have one segment, one very long segment which is level, and the other one is, it has a gradient, right? Okay, and this gradient can be up or down, so that's why 3. Okay, not level, rolling and extended gradient. Level, upward gradient, downward gradient. Okay, for level EHV is, where did it go? Oh, okay. For level it is 2. Okay, now they said heavy mix. Okay, so this is heavy mix. 30% trucks and single unit trucks, 70% trailer trucks. Okay, I have, what's the gradient? 4.5%. 4.5% is here. Okay, the length is how much? 2 miles. I don't have 2 miles, I have only 1. I'll take the last value. Got it? Okay, 15% trucks. 4.5 last value because 2 is not available, and 15% trucks. So 3.11. This is upward. Then for downward, I'll go up again, the last value. Okay, only negative value I have is -2, so I'll take it from here. Okay, length again, I don't have 2, I have 1.5 only. Last value again. For 15% trucks, 2.04. Okay, so what are my FHV values? So you have to change these one by one. 87, 76, 86, so almost 87. Almost 87. Okay, why it is almost same? Because you look at the factors, they are also almost same. This makes sense. Some of you will keep it 0.86, right? And do one more set of analysis. Okay. We are doing it for this equation. So now we have just one unknown. We have just one unknown, okay, which is called maximum flow rate, maximum service flow rate. Okay, this is where I need to explain to you, and this is where the graph comes into play. Okay, and this is where I will leave it for you to do it for this one and for your term projects as well. Okay, maximum service flow rate for level of service C. Okay, and they said, okay, you can do up to D as well. So I need two values for maximum service flow rate. One for C, one for D. Okay, these values will come from the speed flow curve. From the speed flow curve, this curve. This one. Okay, so we need to plot that. We need to plot it. Okay, the first point of the curve is very easy because it is what? Free flow speed. Okay, so you start from free flow speed. This will continue up to what? Breakpoint. Okay. What is my breakpoint? It's a free flow. It's a freeway. So my breakpoint will be coming from here. Okay. So what is my breakpoint? One 1056 passenger car per hour per day. Okay. So let me now go to the graph. It's already there in the slides. The rest of the things I will explain from there. Okay. So the first point on this graph is free flow speed. Okay. The y value, the first y value is 73.6. You start from there. Okay. Then you draw a straight line. Okay. Up to what point? Up to the point where you will get 1056. Okay. So the first point is free flow speed, then a straight line until you reach 1056 here. Got it? Okay. After that, the curve is going down. Okay. Now, I will go directly to the last point of the curve. Okay. What is the last point of the curve? Capacity. Okay. So to plot the last point of the curve, I need capacity. Okay, what is the capacity here? Which is more than the range, right? Which is more than the range. Okay, so it cannot be 2436, it can be only to the half one. Okay. Now is this, I am drawing the curve, right? So this is the x value. I still need the y value. Okay, x and y, right? I need x and y both. So the y value will come from this equation. Okay, let me call it my critical speed. Okay, so I have free flow speed. I go up to breakpoint. The next point is the end of the curve, which is capacity. And the y value at this point, this value will come from this equation, okay, which I am calling as what? Critical speed. Okay. Okay, if you look at the graph, you can see the critical speed is somewhere near 52 or something. Okay. It's coming from that equation. Clear? Okay. Now it's a curve, right? It's a curve. I have the first point, which is the break point, and I have the last point, which is the capacity. Okay. If I join it, I will join it with a straight line. If I have to join 2 points, I join them with a straight line, right? Okay. So which will not give me the correct shape. Okay. To make it more accurate, I should have more points. Okay. So I can join it with more points, so it will make complete shape. Okay. Now I don't know which points are these, but they must be between what? They must be between, okay, they cannot be more than capacity, right? And they cannot be less than
Between break point
between breakpoint and
and capacity.
capacity. Okay. Okay. Now any point between them is fine. Huh? You're talking about yourself. Huh? Any point between them is fine. Clear? So my breakpoint is 1056 and my capacity is 2400. Okay. Somebody says I will take 1500 and 2000. I'll take 2 extra points. One at 1500, one at 2000. Fine. No problem. Okay. Somebody says no, I will take one at 1200, 1400, 1600, 1800, so on and so forth. Okay. So it will be more accurate. Okay. So as long as you are in this range, okay, any point you select is fine. Selecting more points will make it more accurate. Okay. One thing which I should have mentioned, when you are calculating SC, critical speed, so you use this equation, right? Free flow speed, you know. DC, this one. Capacity, you know. What about VP? A is given in the table. A is here. So A is not a problem. What about VP? If I am calculating SC, and what is my VP? VP was a flow rate, right? Flow rate at which I am calculating the speed. Flow rate at which I am calculating the speed. Okay, so I am calculating the speed at capacity. So VP and C will become equal here. Only for this point. Only for this point. Clear? Okay. So now for the other points, the VP will be somewhere between them. So if you say I will calculate speed at 1500 and 2000 between them. So once you will put VP as 1500, then you will put VP as 2000. Okay, clear? Okay, we are trying to make this curve, and we know the curve exists between breakpoint and capacity. Okay, so between these two you will try different values. These values will give you S. What is S? My Y value. What is your X? The values you are trying here. Okay, so VP is your X value and S is your Y value. Okay, so you will have a set of points. Okay, so I'll make a table here. First point, free flow speed and 0, right? Flow 0, speed, free flow speed. Second point, free flow speed, break point. Okay. Third point, capacity, SC, capacity. Okay. Rest of the points, anything between them. Okay, and for each point you will calculate the S values. Okay, and then you plot your graph using these values. Clear? You have to try it, obviously. Okay. Now, we are doing this to find out what is my maximum service flow rate at level of service C and D. We are trying to find out maximum service flow rate at level of service C and D. Okay. This graph is plotted, then you have to plot the lines which indicate where is level of service C and D. Okay. For that, I'll go to this table which tells me the density. Okay. Now density was what? Vp upon S, right? Flow upon speed. Density is flow upon speed. Okay. So you, for example, I am looking for this one, C and D, right? So at C, the density is, maximum density is 26. So this is flow upon speed, right? This is flow upon speed. So I am looking for a line. When you take the ratio of flow upon speed, you will get what? 26. Okay. And they said you can do it for D as well, right? So I'm looking for another line. When I take the ratio of flow upon speed, it gives me what? 35. Okay. Okay. Now you can see these lines are plotted. Okay. Now I have to plot the line. You will go from the origin. So you have the point. Now you need what? The angle. Okay. Now if you are taking the angle from here, okay, from the speed axis, this is what I did here. Is it written? Not written. Okay, fine. I'll make it easier for you. You need what? The angle of the line, which is should be equal to density, right? Density is what? Flow upon speed. Density should be flow upon speed. Okay. What is tangent theta? Tangent theta is what? What upon what? Y upon x, right? Tangent theta is y upon x. Okay. I need my y to be what? Flow. Okay. I need my y to be flow. Okay. So I will my x to be speed. Okay. So the maximum density for level of service C was 26. Okay. The maximum density for level of service C was 26. This will become my tangent theta. Okay. Now I'm looking for this angle. Okay. I'm looking for this angle. If you are looking for this angle, you have to do the inverse. Okay. If you take this angle, it should be direct. Okay. So tangent inverse of 26 will give you this angle directly from the speed axis. But I'm saying the other way around. Other way around. The angle should be from the base, right?
Yes.
Okay. It is flow upon speed. Yeah, the base. Fine. Correct. Okay. So this angle will be the inverse of density. Okay. This angle will be the inverse of density. Okay. So inverse of density C will give you this angle for level of service C line. Okay. And if you take the inverse of 35, which was for D, then it will give you the angle for this line. Okay, from here. From here. Yes. Okay, so you plot the graph, you go to the level of service C and D, you find out the tangent inverse, you plot the lines according to the angle. Okay, now where the lines are intersecting, this becomes your maximum service flow rate. It's given here somewhere. Yeah. So for C, you can see the line is intersecting the curve at 1747. For D, the line intersecting the curve at 2108. Okay. So if your road has flow rate less than this, then your level of service is C or less, or C or better. If your highway has flow rate 2108 or less, your level of service is D or better. Okay. Going back to the number of lanes, we are trying to find out the number of lanes. Okay, number of lanes has volume. This is my volume, given volume, design volume. This is my peak hour factor. This is coming from here. The maximum service flow rate for C. Okay, the maximum service flow rate for C. And this is my FHV factor. Okay, how many FHVs we have? This one and this one. Okay, this is for level, which is same as downward gradient, and this is for upward. So you have two number of lanes. Okay, one for level and downward, one for upward. Okay, so they have calculated these two using the level of service C. Both of them are for level of service C. Okay, and you get 2.39 here, 2.11 here. Okay, now how many lanes you will actually give? 3, 2, rounding up, rounding down. Huh? Rounding up or rounding down?
This is for C, right?
Yes.
But there's no problem to make it B.
Yes.
Yeah, so round down.
Yeah, we can. We can round it down, but that means we will go to the minimum.
Yeah.
Okay, we go to the minimum then. Okay. The only problem with that is in future or whatever design volume you have taken, if because of some reason the actual volume is more than that, okay, or the growth rate of traffic increases, then you will not even have D. Okay, if I make it 3, I may be doing better than C right now. So even if there is some error in my design volume or I have unexpected growth in traffic, I may still maintain C. Okay, according to the question data, you can round down and you can maintain D as well. They are saying okay, that is also fine. Okay, but practically it may create problems when the highway is actually operating. Got it? Clear? Okay, you can try the calculations of this question, okay, yourself. You have the values to match, okay, and you have to do it for your term projects as well in any case. Okay, for your term projects, you have to be careful when you are plotting the graph in Excel, or you can use some other software, maybe use MATLAB or something. Okay, because usually the Excel either it plots the whole curve or the whole straight line or something. Okay, so it's not so a high level. Okay, so you may try it in MATLAB, or maybe there's an option in Excel which I don't know. You can have a go. Clear?